Good morning all. Today we are going through last module of our embedded system course syllabus, and it is mainly focusing on real-time operating system, and this operating system is mainly used for real-time application in the embedded domain. This is the outline of this session. Initially I'll give an introduction to operating system, because in order to understand the real-time operating system one should have a clear understanding of the operating system. So initially I'll give an introduction to operating system, and it includes the operating system structures and operating system services. And since real-time operating system is a part of operating system or a classification of the operating system, the operating system structure and operating system services of a real-time operating system is almost similar to the general operating system structure and operating system services of a general purpose operating system. Then I will move on to the real-time operating system concept, and then I will discuss various classification of this real-time operating system. You already familiar with the operating systems, because in your day-to-day life you are using operating system for various electronics devices. In a mobile devices we may be using an Android operating system or an iOS operating system, and in the case of a PC you may be using a Windows operating system or a Linux operating system, and sometimes a Mac operating systems. And this operating system manages all the hardware peripheral on which this operating system is installed. So the main functions of an operating system is to manage the hardware, and it also provide an environment for the application software which we installed on that computer or on that devices. So an operating system is defined as it is a software that manage computer hardware software resources and provide common services for computer programs. So here you can see basic structure of an operating system. Here there is one hardware devices, and there is one user and some applications. So this operating system acts as an intermediary between the user application and hardware devices, and here the operating system manage all the component of the hardware devices, so that the user application doesn't need to understand the internal implementation of the hardware devices. So the main use of this operating system is to hide the internal complexities of a hardware devices from the user application, and this operating system will manage all the hardware devices which is attached to the operating systems, or all the hardware devices which is present in the systems. So the user application doesn't need to worry about the internal implementation of this hardware. Now we can discuss different types of operating systems. Depending on the number of tasks or number of processes the operating system can run at a time, the operating system is classified into single tasking operating system and multitasking operating system. In a single tasking operating system, the operating system can run only one task or one programs at a time. But in the case of multitasking operating system, the operating system will permit to execute multiple processes or multiple tasks concurrently or simultaneously through a time shared manner. Here the operating system allocate a portion of the CPU time slices to each processes. So each process can run simultaneously in a time-shared manner. If there is multiple core present in the CPU, then the operating system can allocate different core to different processes. So if there is only one core is present in the CPU, then the operating system can allocate different time slices of the CPU to different processes. In either case, the multitasking operating system can run multiple processes or multiple tasks simultaneously. So it is defined as a single tasking operating system can run only one program at a time, while a multitasking operating system allows more than one program to be running in concurrency. The next classification of the operating system is the single user operating system and multi-user operating system. And this classification is based on the number of users which is accessing the operating system at a time. If there is only one user is able to access the operating system at a time, then the operating system is called single user operating system. If multiple users is able to access the operating system at a time, then it is called multi-user operating system. Almost all new operating system or new types of operating systems are multi-user operating system. And this example of this multi-user operating system are Windows 7, Windows 10, Windows XP, Linux, which include Ubuntu, Fedora, CentOS, etc., and Android operating system and Mac operating system. But in olden days, the almost some of the operating systems are single user operating system. And the example of single user operating system are Microsoft DOS operating system and Windows 95 operating system. So a single user operating system is defined as an operating system which have no facility to distinguish users, but may allow multiple programs to run in tandem. But in the case of multi-user operating system, it permits multiple users to interact with the system at the same time. And the next type of operating system is distributed operating system. Here a distributed operating system which manage a group of distinct network computers and make them to appear to be a single computer. So there is multiple node in the computer, and this distributed operating system manage all node in the computer and make them appear as a single computer. Next type of operating system is the embedded operating system. And this embedded operating system is specifically designed for an embedded system. We know that an embedded system has a very limited resources. It means that it has very limited CPU performance and very low memory capacity. So here we use an embedded operating system which is specifically designed for this embedded system. So it can manage this very limited resources very efficiently. So the embedded software operating system are designed to be used in embedded computer systems and are very compact and extremely efficient by design and are able to operate with a limited amount of resources. It means that general purpose operating system cannot be used in this embedded environment because this general purpose operating system need higher resources like higher CPU performance and higher memory capacity. So we are using an embedded operating system in embedded environment because it only need very low resources such as low memory capacity and low CPU performance. The next type of operating system is the real-time operating system, and it also known as RTOS, and it is used in embedded applications where real-time performance of the process is necessary, and it has a better real-time characteristic than any other types of operating system. So it is defined as an operating system that guarantees to process event or data by a specific moment in time. So we will get a real-time performance by using this real-time operating system, and it also need very little resources than all other types of operating system. Here you can see the structure of an operating system. We know that operating system acts as an interface between the hardware and the user application. So there will be one hardware and there will be one user application, and here there is one operating system. So this operating system is acting as an interface between hardware and the software, and inside that operating system there will be some operating system services, and then some system calls and a graphical user interface and command line interface, etc. So in the operating system services, it has some program execution service, IO operation service, file system service, communication service, resource allocation service, accounting service, error detection service, and protection and security services. And this operating system interacts with the user application using some GUI interface or command line interface. So it also has some user interface which includes graphical user interface and command line interface, and it also supports some jobs which can be run in another time using batch jobs or batch system jobs. And there is one system call interface also there, and this system calls is used for communicating between user programs and the operating system. So this user program can be communicated with the operating system through only this system calls. So this user program cannot access any of these services other than the system calls. And using this system calls, the application can communicate with the operating system's services, and then using that operating system services, the application can access the hardware. Now we can go through various services which is offered by the operating system. The first and the main services of the operating system is the program execution. We know that in an operating system we can execute multiple programs or multiple tasks at a time, and this execution of the application or the program is done using this program execution services of the operating system. So for execution of a program, the program needs some memory and CPU resources, and sometimes it needs some IO devices also. So this resource allocation and the execution of the program is handled by the program execution service of the operating system. So it handles the program execution, and it also provides the mechanism for process synchronization. And this process synchronization is mainly dealing with the CPU scheduling. It means that each process or each application is allocated to different CPU time slices for execution of the process, and this time slices and this managing this process also done by this program execution services. The next operating system services is the IO operation services, and this IO operation services handling various IO devices attached to the system, and these IO devices can be a keyboard or mouse or monitor in a computer. But in the case of an embedded system, these IO devices can be various sensors and actuators. And for the proper operation of the application or process, these applications and process need to communicate with the various IO device attached to the system. And the IO operation services of the operating system handles these IO devices. So the application need not to consider or need not to worry about the various hardware specific configuration of the IO devices, because this IO devices is handled by the device drivers installed in the operating system. The next service of the operating system is the file system manipulation service. We know that in a computer there will be some hard disk, and in the case of embedded system there will be some memory card, and this secondary storage devices like this memory card and hard disk is used to store some data and programs. And the file system manipulation service of the operating system is used to handle this secondary storage devices. So this file system manipulation service contains some functions and APIs for handling these devices. So it says that the file system manipulation service provide an interface to the user to accessing files and directories inside the secondary storage devices. And the next service of the operating system is the communication services. It is very important services given by the operating system, because in an operating system there will be multiple programs or multiple applications running simultaneously. In such cases, one program may need to access the other program's data, or one program need to communicate with the other program. Such times the communication services will taking care of the communication between two processes. And in order to attain a communication between the processes, the operating system provide various interprocess communication mechanisms. Using this interprocess communication mechanism, the operating system allows applications working in the operating system to communicate with each other. The next service is the error handling services. We know that if an application executing incorrectly, it may induce some error, and this error is handled by the operating system. Sometimes the error need to be logged and need to be reported for error correction. All these activities is done by the error handling service of the operating system. The resource management service of the operating system is used to manage various resources attached to the system. In a computer or an embedded system, the major resources attached to the system is the CPU. So the operating system CPU scheduling algorithm is used to manage the CPU utilization for different processes. And other type of resources include keyboard, mouse, monitor and various communication devices, which is in the case of computer. And in the case of embedded system, these resources can be various sensors and actuators. And this resource management service of the operating system will help to manage these devices or these resources properly. The next service of the operating system is the protection and security services. In an operating system, we can execute multiple applications simultaneously. Such a time, it should be important that no application should interfere with each other. And for ensuring this condition, the operating system uses a logical namespace. And this it means that each application is running in different logical namespace, so the application cannot interfere with each other. And operating system also prevent the access of resources by unauthorized users. And this feature is also included in the protection and security service of the operating system. So far we have seen what is an operating system, then what are the services offered by the operating system, and we have seen various classification of the operating system. Now we are moving on to a particular type or particular classification of the operating system, which is called as real-time operating system, and it is used to serve real-time application, and it is mainly used in embedded environment. And these are the components which we can see in real-time operating system. There should be one scheduler in the real-time operating system, and this scheduler is optimized for real-time application. And there should be symmetric multiprocessing system, and there should be memory management system, and a user-defined data object and classes, and a fast dispatch latency, and it has a function library, and these all parts are included in the real-time operating system. We have studied that a real-time operating system is an operating system which is used for real-time application or real-time needs. For handling this real-time application, the real-time operating system should have an advanced scheduling algorithm, and this advanced scheduling algorithm give the real-time operating system all its characteristics. So due to this advanced scheduling algorithm, the real-time operating system has all these three features: the minimal interrupt latency, and well-defined time constraints, and well predictability. And these three features is achieved using this advanced scheduling algorithm which is present in the real-time operating system, and it is dedicated to narrow set of application. Unlike the general purpose operating system, the real-time operating system is dedicated to narrow set of application and also operating very fewer resources. So this real-time operating system can operate with low memory and fewer CPU performance. Here we are going through the various classification of real-time operating system. Based on the CPU scheduling, real-time operating system is classified into two: event-driven system and time-shared system. In an event-driven system, the flow of program is determined by events such as user action, sensor output, and message from other program or thread. And in event-driven system, the task is switched based on their priorities. So we can say that in an event-driven system, the flow of the program is depending on the user action, sensor output, and message from other programs or thread, and task is switched based on their priorities. And another type of or another classification of the real-time operating system based on the CPU scheduling is the time-shared system. In time-shared system, the operating system uses a CPU scheduling and multi-programming to provide each user with a small portion of the shared computer at once. And a time-shared system switches task based on the clock interrupt. So in a time-shared system, each process will get a slice of CPU time. So each process can execute simultaneously, and each process will get a slice of CPU resources. Depending on the time characteristic of the real-time system, the real-time system is classified into three: hard real-time system, firm real-time system, and soft real-time system. And in the case of hard real-time system, missing a deadline is a total system failure. It means that the hard real-time system is expected to respond within the time bound or within the deadline. And if the system is not responded within the deadline, then it will cause a system failure. But in the firm real-time system, infrequent deadline misses are tolerable and it won't cause a system failure. But it is expected to have a response within the deadline. But in the case of soft real-time system, it is also expected to have the result within the deadline, and missing the deadline also not cause a system failure, but the usefulness of the result or usefulness of the system will degrade when it misses a deadline. So like a real-time system, the real-time operating system is classified into two types: hard real-time operating system and soft real-time operating system. In a hard real-time operating system, the operating system can meet the deadline deterministically. It means that it can respond within the time limit, and it also has less jitter. But in the case of soft real-time operating system, it can meet the deadline but not deterministically. It means that sometimes it is possible to miss the deadline, but it will respond to the input, but sometimes it may miss the deadline. Now we can go through various applications of real-time operating system. Depending on the application type, we can select either hard real-time operating system or soft real-time operating system. For a time critical application, we are normally preferring hard real-time operating system, because hard real-time operating system giving the output or giving the response within the deadline. And these are the examples of hard real-time operating system applications. Here you can see car engine control system, which is using hard real-time operating system, because in a car engine a delayed response causes engine failure. So by using hard real-time operating system, we can ensure the output or response come within the deadline. And next is the medical system like a heart pacemaker. Here failure will cause potential risk to human life. So since it is a time critical application, we can go for hard real-time operating system. The next one is industrial process controllers such as machine on assembly line. Here failure will cause product on the assembly line could pass beyond the reach of the machine. So entire system, entire the assembly line will go to a failure stage. And the next one is the printers. Here in printers, a failure will cause either missing output or misaligned output. So in printers, this failure is not permissible. So we are going for hard real-time operating system. So it is an example of hard real-time operating system. Now we can go through applications of soft real-time operating system. This soft real-time operating system is also used for real-time application, but this application should not be time critical. And these are some examples of soft real-time operating system. The first one is the software that maintain and update flight plan for commercial airliners. Here flight plan must be kept reasonably current, but they can operate with a latency of few seconds. It means that a few seconds miss of the deadline is not causing a problem. So it is an example of soft real-time operating system. And next one are washing machine and mixer grinder. Here this washing machine and mixer grinder operate based on user input. And if the washing machine and mixer grinder respond after 1 second of the user input, then it won't cause much problem. So it is also an example of soft real-time operating system. Now we can go through the comparison of real-time operating system versus general purpose operating system. The general purpose operating system is mainly used for desktop PCs and laptop. But in the case of real-time operating system, it is used for embedded systems. And this general purpose operating system uses a process based scheduling, while the real-time operating system uses a time-based scheduling. And the interrupt latency is not considered important in the case of general purpose operating system. But in the case of real-time operating system, the interrupt latency should be kept minimal, and it should be in the order of few microseconds or less. And the general purpose operating system can be used for vast set of application. So lot of application can be run on this general purpose operating system. But the real-time operating system is dedicated to narrow set of applications. And the general purpose operating system also has higher memory and processing power. But the real-time operating system is operating with limited processing resources and limited memory. And the time constraint of the general purpose operating system is not defined properly, but the real-time operating system should have a well-defined time constraint. Now we can go through some popular real-time operating systems. Here you can see some popular real-time operating systems. And some of these operating systems are free and some are commercial. Here you can see these operating systems are RTOS, MBOS, Free RTOS, Integrity, Keel RTX, Lynx OX, MQX, Nucleus, Neutrino, PikeOS, Safe RTOS, ThreadX, MusiOS, VXWork, and Sapphire. So far in this session we have studied about operating systems and a various classification of the operating system. Then we have seen various services and structures of the operating system. Then we have moved on to real-time operating system, and then we have seen classification of the real-time operating system. Then we have seen some examples of real-time operating systems. So I am winding up this session. Thank you. See you tomorrow.